Today, we are going to continue our discussions regarding finding the area under a curve. So I have here some formulas to be used if the two curves are given. Under the conclusion number 4, so as you can see in the figure A, we have here the upper function and the lower function. So in the first figure on the left, I would say that f of x is our upper function and the lower function is the g of x. In similar manner in the second figure, so in the upper function still f of x and the lower function is here, which is the g of x. So we have the same formula to be used for this, as well as in the third figure, as we could say that the function f of x is the upper function, while the other one, g of x, is the lower functions. So in these three figures, we can use the formula for finding the area. The area is the integral of f of x minus g of x dx evaluated from a to b. So in the figure 4.b, so we have here three areas. I will name that one as area A, area B, and area C. From the interval A to B, our upper function is the red one, which is now the f of x, and the lower function is the blue one, which is the g of x. So in that case, the formula for the area A is equal to the integral of f of x minus g of x dx evaluated from A to B, plus the area B. As we can see from the interval B to C, we could see clearly that the upper function is the blue one, which is now the g of x, and the lower function is the red one, which is the f of x. Therefore, the area now of this area B will be equal to g of x minus f of x dx, evaluated from B to C. And the last area here, we have the area C. As we can see that the upper function is the red one, which is the f of x, and the lower function here is the g of x. That is why we have the formula of the f of x minus g of x dx evaluated from C to D. So to find the total area of this figure, so we will just sum up the area A plus B plus C will be equal now to the area of f of x minus g of x dx evaluated from A to B plus the integral of g of x minus f of x dx with the interval of B to C plus the integral of f of x minus g of x dx with the interval of C to D. Now let's put this one into an example. So for number 6, we have find the area of the finite region between the graphs of y sub 1 equals x squared plus 1 and y sub 2 equals 5. So to do this, since the interval is not given, then we are going to solve for the intervals by equating the two equations. So we can write here as y sub 1 is equal to y sub 2. So by substitution, I can write now x squared plus 1 is equal to 5. So solving now for x, so we have here x squared is equal to 5 minus 1 equals 4. And x now will be equal to plus and minus 2 because we take the square root of 4. So the intervals now is from negative 2 to positive 2. And after that, we are going now to write the formula. Based on the graph, the upper function is the y sub 2 and the lower function is the y sub 1. Okay, so or there's another way to determine which one is the upper function and the lower function by letting the value of x whose value is in between the limits. Shall we say from negative 2 to positive 2. So shall we say that I will use x equals negative 1 since negative 1 is a value that is in between negative 2 to positive 2. Now, if I'm going to test if x equals 2, if x equals negative 1, then y sub 1 is equal to negative 1 squared plus 1, that is now equal to 2 because the square of negative 1 is 1, so plus 1 is equal to 2. Then y sub 2 is just equal to 5. So comparing the two values, we say that y sub 1 is greater than, so based on the value of y sub 1 and y sub 2, since y sub 2 is already a constant, so no need to solve for that, then we can compare now the two values of y sub 1 and y sub 2, and we could say now that y sub 2 is greater than y sub 1. Therefore, we could say that y sub 2 is the upper function and y sub 1 now is the lower function. So that is now one way of determining which one is the upper function and the lower function without the graph. Okay, then after that, we are now going to write our formula for finding the area. So now our area, now we have area is equal to the integral of y sub 2, which is now the upper function, minus y sub 1 is the lower function of dx, which has the interval of negative 2 to positive 2. As you can see here in the graph, that is now from, so the intersection points is actually our intervals. So we have here from negative 2 to positive 2. Now, by substitution, let us simplify our integrand. So we have the integral now of y sub 2 is 5 minus x squared plus 1 of dx, evaluated from negative 2 to positive 2. So by simplifying that, we can write now as the integral of 4 minus x squared of dx from negative 2 to positive 2. So we are going now to integrate that one. So that is now, we have, so the area now is equal to 4x minus x cubed over 3 evaluated from negative 2 to positive 2. Now, if we are going now to evaluate that one, so we have now the area will give us, by substitution, we can now write, we have 8 minus 8 over 3 minus the negative 8 minus of the negative 8 over 3. So by simplifying that, so you may just use now a calculator because I'm running out of space. So therefore, the answer will give us now 32 over 3 of square units. For number 7, we have find the area of the region bounded by y sub 1 equals x squared plus 2 and y sub 2 is equal to x plus 4. So this is almost similar to problem number 6. So first of all, we're going to equate the two functions or the two equations. So therefore, it becomes now y sub 1 is equal to y sub 2. So we will do like this if there is no interval given. So we have now by substitution, this is now x squared plus 2 is equal to x plus 4. So solving for x, we need to transpose. So we have x squared minus x, and this will be now 2 minus 4 is negative 2 is equal to 0. And then factor this one. So we can factor that one out as x minus 2 times x plus 1 is equal to 0. And then equating each factor to 0, so we can write now x minus 2 is equal to 0, and the other one is x plus 1 is equal to 0. Therefore, solving for x, so we have now x is equal to 2, and the other one is x is equal to negative 1. So these values now are the intervals for this curve. Upon looking at the graph, we could say that the upper function is the y sub 2, while the lower function is the y sub 1. So using the formula, area is equal to the integral of y sub 2 minus y sub 1 of dx, evaluated from negative 1 to positive 2. So by substitution, we have the integral of our y sub 2 now is x plus 4 minus x squared plus 2 of dx. So evaluated from negative 1 to positive 2. And by simplifying that, so we can now have the integral of the negative x squared plus x plus 2 of dx, so with the interval now of negative 1 to positive 2. Okay? So by integrating that, we can now have the area is equal to the negative of x cubed over 3 plus x squared over 2 plus 2x, evaluated from negative 1 to 2. Now, if we are going to substitute that one by using the fundamental theorem of calculus, then it will give you now the answer for the area of 9 over 2. Okay? So, I forgot to show you the other method for determining whether which of the two function is an upper function or the lower function. So I will just confirm whether the y sub 2 is really the upper function. Since the limits is from negative 1 to 2, I will try to use 0 as the value of x, because 0 is in between the limits. So if x is equal to 0, then y sub 1 is equal to 0 squared plus 2. We have equals 2. And y sub 2 now, we have 0. X plus 4 is 0 plus 4 is equal to 4. So we could say now that y sub 2 is greater than y sub 1. Then it follows that y sub 2 is our upper function and y sub 1 is our lower function. So number 8, find the area of the region bounded by f of x equals x squared minus x and g of x equals 3x minus x squared. First of all, we're going to equate the two functions. So therefore, this can be written now as f of x is equal to g of x. So we can write now x squared minus x is equal to 3x minus x squared. So transposing that one, so this will become now, we have x squared, transpose, this becomes 2x squared minus 4x is equal to 0. Since there are only two terms and we could say that there is a common factor of 2x, so therefore 2x is a common factor and divide. That is now 2x squared divided by 2x is equal to x minus 4x divided by 2x. We have negative 2 is equal to 0. Okay, so we have now the factors of 2x and x minus 2 is equal to 0. So equating now each factor to 0, so we could write 2x is equal to 0, and the other one is x minus 2 is equal to 0. Solving for x, this one now is 0, and the other one is equal to positive 2. So the interval now is from 0 to 2. So if we're going to confirm that one now from our given graph, so the intersection point here is 0, and we have to find the area wherein the intersecting point of the two curves that is now in the value of x now is equal to 2. So the interval is from 0 to 2. So by looking at the formula, okay, so it's up for you now to confirm. You have to test the value of x for you to find whether which of the two functions is upper function or the lower function. But by this time, I will just base it on the graph. So it is clearly that the upper function is the g of x, and the lower function is f of x. So I will write here, so the area is equal to the integral of the upper function now is the g of x. So g of x minus f of x, the lower function of we have dx, whose interval now is from 0 to 2. So by substitution, we have the integral of g of x, which is now 3x minus x squared, minus the f of x, we have x squared minus x of dx, whose interval is from 0 to 2. Now, by simplifying the integrand, so it will give us now the negative of 2x squared plus 4x of dx from 0 to positive 2. So by integrating that one, we can write now negative 2x cubed over 3 plus 4x squared over 2, simplifying, that is now 2x squared, and then evaluated from 0 to 2. So the area now, if you're going to solve for that by using the fundamental theorem of calculus, then it will just give us the value of area of 8 over 3 square units. Number 9, find the finite area between the graph of y equals x cubed, y equals 0, x equals negative 2, and x equals 1. So in this kind of problem, our intervals here is coming from negative 2 to positive 1. But if you're going to look at the graph, so we have here from negative 2, and then there is an intersecting point of 0. Okay, because the area under this graph, we have two areas which is located in the third quadrant and on the first quadrant. So in that case, we are going to have a two integrals, which is now the first interval is coming from negative 2 to 0, and the other one will be from 0 to 1. So, writing the area now of this problem, so we could say that the area is equal to the integral of x cubed dx. But since that is in the third quadrant, that is below the x-axis, so I will write now as the negative x cubed of dx. Then the interval now is coming from negative 2 to 0 plus the integral of x cubed. This is now positive because that is in the first quadrant or above the x-axis. So the intervals now here is coming from 0 to 1. Okay, so in other words, we're just breaking the intervals from negative 2 to positive 1 by applying the properties of definite integral. Okay, so we have now to integrate. So this one is negative x to the power of 4 over 4. And this is evaluated from negative 2 to 0 plus the second term, we have x to the power of 4 over 4, and that is evaluated from 0 to 1. So by using now the fundamental theorem of calculus, so this will give us now the answer of, we have 0. If we are going to substitute 0 here, and that becomes 0, and then minus, we have the negative of negative 2 to the fourth power over 4, and then plus the second term, we have the upper limit is 1. So this 1 to the fourth power is 1 over 4. It's now 1/4. And the lower limit is 0. So just right there, 0. Now, by simplifying that one now, it will give you now the answer of 17 over 4. Okay. Number 10, find the area of the region bounded by y equals x cubed, x equals 0, y equals -2, and y equals 2. So the last two given, which is y equals -2 and y equals 2, it only tells us that this graph is in the y-axis, wherein the limits is from -2 to +2. But since the graph is also given, as you can see here, we can find two areas. We have the area A and the area B. So from area B, we have here from -2 to 0, which is the intersection point. And then the other one is from 0 to +2. So using the formula of A is equal to the integral of f of y dy, since I have stated that the given tells us that this is in the y-axis. So we have here from, I will write first as A to B. Okay, and then solving this one, y is equal to x cubed, we need to solve x in terms of y. So we have y is equal to x cubed. And then to solve for x, we need to take the cube root of both sides. Therefore, x now is equal to the cube root of y. Now, so we are going now to write the formula. For the area, we have area is equal to the integral of the cube root of y dy. And looking at here in the graph, so we can start first from -2 to 0. This is now from -2 to 0 plus the other one from the area A. So we can write now from 0 to +2. So we have 0 to +2, which is the integral now is the cube root of y dy. And now we are going to simplify that one. So we have now y to the power of 1/3 of dy. So I'm just rewriting in from radical form into a fractional exponent. So from -2 to 0 plus we have y to the power of 1/3 of dy from 0 to +2. So take a look again on the area B, which is now below the x-axis. Therefore, I need to write here the negative sign and the negative sign for the area B because it is below the x-axis. And the second one, the area A is above the x-axis, so therefore it's only positive. Okay, so therefore, we have to integrate this one now. We have the negative of 3/4 of y to the power of 4 over 3 evaluated from -2 to 0 plus integrating now the second term. So we can have 3/4 of y to the power of 4 over 3 evaluated from 0 to 2. Now, in this area B, I'm repairing this one to area B, and the second term is for area A. Evaluating this one, that will give us now the answer of 3 over 2 times the cube root of 2 plus the other one, we have 3 over 2 times the cube root of 2. Or we could say that it is, we have 3 squared the cube root of 2 over 2 plus 3, the cube root of 2 over 2. So if you're going to add that one, it will just give us now 3 times the cube root of 2. Number 11, what is the area of the region bounded by y equals x squared plus 3x, the x-axis, and the line x equals 3? So this curve is for our quadratic equation. We have y is equal to x squared plus 3x, and the other one now is x equals 3, the linear or the straight line or the linear equation. Now to solve for this, so in this graph, there are two areas of the region bounded by this graph. We have the area A, which is now below the x-axis, which is located in the third quadrant, and area B is above the x-axis, which is now in the first quadrant. Now, to solve for that, I'm going to separate the two areas. So the total area for this will give us A plus B is equal to the integral of the negative of x squared plus 3x of dx evaluated from negative 3 to 0 plus, for the area B, we have the integral of x squared plus 3x of dx to positive 3. So we can also do the same in this kind of solution on our previous example. Okay, so finding now the integration for this, so we need to simplify first. So the integral of the negative x squared minus 3x of dx from negative 3 to 0 plus the integral of x squared plus 3x of dx from 0 to 3. Now integrating that one, so we can now write as we have the negative of x cubed over 3 minus 3x squared over 2. This is now evaluated from negative 3 to 0 plus, on the second term, we have x cubed over 3 plus 3x squared over 2 evaluated from 0 to 3. So using now the FPC, so therefore this will give us now the area of 27. So you will just use your calculator. Okay, there are some important formulas to be discussed here. So to determine the area between y equals f of x and y equals g of x on the interval a b, we're also going to assume that f of x is greater than or equal to g of x. So the formula now, based on the graph on the right side, we have the area is equal to f of x minus g of x dx from a to b. So I would say that f of x is our upper function and minus the g of x here is our lower function. Okay, so that's the formula that we are using, and that's the one that I'm trying to emphasize in the beginning of this discussion. And also, to determine the area between x equals f of y and x equals g of y on the interval of c, d, with f of y is greater than or equal to g of y. So based on the graph, we could say that the area is equal to the integral of the right function minus the left function from c to d. Or I could write the formula now as a area is equal to the integral of f of y minus g of y of dy evaluated from c to d.